Newton's laws of motion. Isaac Newton, 1642 to 1727, was an English mathematician, physicist, astronomer, and author, widely recognized as one of the most influential scientists of all time. He is best known for his work in mathematics and physics, including the development of the laws of motion and universal gravitation. Introduction. Newton's laws of motion are three fundamental principles that describe the relationship between the motion of an object and the forces acting on it. These laws form the foundation of classical mechanics, a branch of physics developed by Sir Isaac Newton in the late 17th century. Here are the three laws that he gave: first law, law of inertia; second law, law of force and acceleration; third law, action and reaction. What is Newton's third law? Newton's third law of motion states that, for every action, there is an equal and opposite reaction. But what does that really mean? It means that whenever you apply force to something, that thing pushes or pulls back with the same amount of force. Action and reaction forces. Action and reaction forces are the pair of forces described in Newton's third law of motion. For every action, there is an equal and opposite reaction. These forces always occur in pairs, and they act on different objects. Key concepts of action and reaction. Force is 1. Equal in magnitude. The force exerted by the first object, the action force, and the force exerted by the second object, the reaction force, have the same magnitude. However, they act in opposite directions. 2. Opposite in direction. The action force is exerted in one direction, and the reaction force occurs in the opposite direction. For example, if you push a wall, the wall pushes back with equal force in the opposite direction. Third, act on different objects. The action and reaction forces never act on the same object. For example, when you push on a table, your hand exerts a force on the table, action, and the table exerts an equal and opposite force on your hand, reaction. 4. Simultaneous forces. Action and reaction forces happen at the same time. Neither force can exist without the other, and they are always present when two objects interact. Examples 1. Rocket propulsion. When a rocket launches, it expels gases out of its engines at high speed in the downward direction, action. In response, the rocket is pushed upward by an equal and opposite force, reaction. This force propels the rocket into the sky. 2. Swimming. When a swimmer pushes the water backward with their hands and feet, action, the water pushes the swimmer forward with an equal and opposite force, reaction, allowing them to move through the water. Third, recoil of a gun. When a gun is fired, the bullet is propelled forward out of the barrel, action. At the same time, the gun experiences an equal and opposite force, which causes it to recoil backward, reaction.